Close your eyes. The quiet science begins. Tonight we gently drift into, what if the sun disappeared? Your skin is still holding sunlight from hours ago, radiating it quietly into the dark, the way the earth itself does every night. There is nothing you need to do with that. It is already happening. It has been happening since before you came inside, since before the light changed color at the edges of the sky. Your body received something and is now, slowly, giving it back to the air around you. That is enough to notice. That is enough to rest with. So there is no pressure here. No destination for your mind to find. Whatever the day was, its weight, its brightness, its unfinished edges, none of that is required in this room. Your body already knows how to be still. It has done this every single night for your entire life, and longer than that, much longer, through every ancestor who ever lay down in the dark and let the warmth in their skin slowly return to the air. You don't have to think about anything carefully. You don't have to follow closely. If your mind drifts somewhere and comes back, that is fine. If it drifts and doesn't come back right away, that is also fine. The only thing happening here is a quiet conversation about something your body already understands, even if your mind has never thought to ask. The room around you is the right temperature. The dark outside is the ordinary dark. The sounds you can hear, if any, are the normal sounds of a world that continues on its own without needing your attention. Rest here. Stay as loose as you can. Let your shoulders be heavy. Let your jaw be easy. We are going to think about the sun together. Not urgently, not as a problem, just as something that has always been there, quietly, and what it would mean, slowly, gently, if one night it wasn't. The sun is approximately 3 million miles away from where you are lying. The others call number that doesn't mean very much when you first hear it. Numbers that large don't quite land in the body. But there is a simpler way to feel it. Light, which moves faster than anything else in the known universe, takes about 8 minutes and 20 seconds to travel from the surface of the sun to your eyes. If you were watching the sun right now, and people on the other side of the world are, what they see is not the sun as it is. It is the sun as it was 8 minutes ago. In a way, no one has ever seen the sun as it actually is in this moment. We only ever see its recent past. There is something quietly stabilizing about that. Even the most immediate and obvious thing in our sky is slightly out of reach, always a few minutes ahead of us, not distant in a way that creates loneliness, just distant in a way that creates a kind of gentle separation. The sun and the earth have always had that gap between them. 8 minutes of light. A gap that everything alive on this planet has grown within, and for billions of years, across every morning and every evening, that gap has stayed almost exactly the same. The sun rises, arcs, sets. The light arrives warm and leaves. The warmth soaks into stone and soil and skin and slowly releases back into the dark. This has happened so many times that the rhythm of it is written into the most basic layers of how living things work. Your own body counts on it. Your hormones follow it. Your temperature rises with the morning and falls with the night, tracking a cycle that has been running longer than eyes existed to see it. You are not just resting in a room. You are resting inside one of those cycles. Right now, in the dark part, in the quiet part, where the body has always known to go still. The question, what if the sun disappeared, is not a frightening one in this telling. It is a thought experiment, a way of seeing something by imagining its absence. Scientists have a name for this kind of thinking. They call it a counterfactual. Not a disaster scenario. Not a prediction. Just a quiet hypothetical that lets you see the thing itself more clearly by imagining the space where it isn't. When a geologist wants to understand a river, sometimes they study a dry riverbed. The absence tells them something the presence couldn't. The shape of what's missing reveals the shape of what was there. The sun is so constant that most of the time it is invisible in the way that very familiar things become invisible. You stop noticing the walls of a room you've lived in for years. You stop noticing the weight of your own hands. The sun is like that, so reliably present that it has become a kind of background hum, something the mind categorizes as permanent and then no longer examines. But for a moment, gently, think about the last time you actually noticed it. Not the glare or the squinting, but the quality of it, the particular angle of late afternoon light through a window, the way it makes a surface look both illuminated and warm at the same time, or the sharp, cold clarity of early morning light in winter before it has softened, or the specific golden tone it takes near sunset, when the atmosphere is thickening and the light has traveled farther through the air to reach you. Each of those is slightly different. The sun produces a range, and you have been reading that range without thinking about it your whole life. Your body knows the difference between 10 a.m. light and 4 p.m. light. Not because you decided to learn it, because you couldn't help it. Light has always been communicating with you, and you have always been listening. Let the body get a little heavier. There is no hurry to anything that follows. The night is long and unhurried. The thoughts ahead are soft ones. Here is something that has a kind of quiet logic to it once you hear it. If the sun were to simply vanish, not explode, not fade slowly, but disappear instantly, no one on the sunlit side of the earth would know for 8 minutes and 20 seconds. The light already traveling toward us would continue arriving. The warmth already in motion would finish its journey. For those 8 minutes, everything would look exactly as normal. The oceans would still be blue. The sky would still be lit. A person sitting on a bench in full afternoon, sun would feel the same heat on their face. The birds that navigate by light would still be navigating. Children playing outside would still be playing. And then, at exactly the same moment for everyone on the daylit side of the earth, the light would stop, not dim. Stop. The sky would go from whatever color it was, the blue of midday, the orange of evening, to absolute black, in less than a heartbeat. Stars would appear instantly, because there would no longer be any scattered sunlight to drown them out. The full, uncurtained night sky would arrive in a fraction of a second. In the middle of the day, that moment, that sudden, complete darkness, is actually useful to sit with, not because it is frightening, but because it shows you something. You would understand immediately, in the body, before the mind had time to process it, that light is not a feature of space. It is something that travels from a source. And without the source, space returns to what it actually is: dark and very, very quiet. This is what deep space is like. Most of the time, almost everywhere. The light you've lived in your whole life is local. It belongs to this small, warm neighborhood around a single star. And the people on the night side of the earth, where you are now, in the dark, resting, would not notice anything at all. Not at first. The night would simply continue. The moon, if it were visible, would remain visible for a while longer, because moonlight is reflected sunlight, and for a little under 1.5 seconds, the light that had already left the sun bounced off the moon and was en route to Earth would continue arriving. So the moon would shine for a moment more. Then it too would go dark. But this would not be visible to anyone who wasn't already watching closely. Most people asleep on the night side of the world would pass through the entire first night without knowing anything had changed. They would sleep through it. They would be exactly where you are now, in the ordinary dark, in the warmth of their own beds, completely unaware. I find that detail stays with me. That the first hours after such an enormous change would look, from the inside of a dark room, like any other night. The world would continue feeling familiar in the way that the world in the dark always feels familiar. Warm surfaces, the sound of the house, the texture of fabric, the rhythm of your own breathing. You wouldn't need light for any of that. The warmth still in the earth. And there is enormous warmth stored in the earth's oceans and crust, warmth collected across billions of years of sunlight. That warmth would not leave immediately. The planet would not go cold overnight. It would cool slowly over days and weeks and months, the way a large stone takes a long time to lose its heat after the sun goes down. For quite a while, the surface of the earth would remain livable. Different, dark, but colder as the weeks passed. but not immediately hostile. The deep ocean, where the sun's light never reaches anyway, would be nearly unchanged for years. So even here, in the thought of the sun's disappearance, there is more continuity than the mind expects. More stored warmth, more inherited light, more time than you thought. The Earth has a memory for heat. This is not a poetic idea. It is literal and measurable. The oceans, which cover more than 2/3 of the planet's surface and run miles deep in places, absorb an enormous amount of solar energy across their upper layers over time. That absorbed warmth doesn't disappear when the sun sets each evening. It releases slowly over hours and days, moderating the temperature of coastal regions, keeping winter nights warmer than they would otherwise be, sustaining the circulation of winds and weather systems that move heat from place to place across the globe. The ocean is, in a sense, a battery, one that has been charging for billions of years. If the sun disappeared tonight, the ocean would begin to discharge that stored warmth into the air above it, not quickly, not all at once. The way a thick stone wall holds the warmth of an afternoon fire into the small hours of the morning, not because the fire is still burning, but because stone releases heat slowly, on its own time, in its own way. Scientists who have modeled this scenario estimate that the average surface temperature of the Earth would drop significantly within the first week, perhaps to well below freezing across most land areas. But the oceans themselves would remain liquid near the surface for much longer, months at least, in the warmer regions. And the deep ocean, where the water is already just above freezing and under enormous pressure, would barely change at all for years. Life near hydrothermal vents, on the ocean floor, those strange ecosystems that have never needed sunlight at all, that run entirely on the chemical energy seeping up from the Earth's interior, would continue essentially unchanged. They would not know anything was different. They have never known the sun. This is one of the more grounding thoughts available in this whole subject. That there are living things on this planet right now, entire communities of organisms for whom the sun has always been irrelevant. Tube worms and chemosynthetic bacteria and small translucent creatures, existing in complete darkness at the bottom of the sea, in water that is near freezing and under crushing pressure, thriving quietly, utterly independent of the star at the center of our solar system. Life found a way in that darkness long before it found a way in the light, or at least alongside it, unaware of it, unbothered. The interior of the Earth is another kind of stored energy. Beneath your feet right now, beneath the floor, the foundation, the soil, the bedrock, the temperature increases steadily the deeper you go. Roughly 25 to 30 degrees Celsius for every kilometer of depth. By the time you reach the outer core, more than 2,000 kilometers down, the temperature is somewhere around 4,000 degrees. Hotter than the surface of the sun in some places. That heat comes from two sources. Some of it is leftover warmth from the formation of the planet itself. 4.5 billion years ago, when countless rocks and dust particles collided and compressed under gravity, converting their motion into heat, the Earth formed hot and has been cooling ever since. But it is so large and rock conducts heat so slowly that the original warmth of formation is still there, still radiating upward through the crust billions of years later. The rest comes from radioactive decay. Certain heavy elements, uranium, thorium, potassium, embedded in the rock throughout the mantle and crust, slowly breaking down into lighter elements and releasing heat as they do. This process is still happening right now, under the room where you are resting. A slow, quiet, continuous release of energy from atoms that have been decaying since before the solar system existed, since before the sun itself was born. The Earth does not depend on the sun for its internal warmth. It carries its own. That warmth drives the movement of tectonic plates, which over millions of years has moved continents, built mountains, recycled the ocean floor, regulated the long-term carbon cycle that has kept the atmosphere breathable across deep time. None of that requires the sun. The engine of that process is entirely internal. You are resting on a planet that has its own slow fire at its center. It has had it since before the sun rose over it for the first time. It will have it long after the sun eventually expands and fades, billions of years from now. There is a kind of deep stability in that. Not comforting in an easy way, just grounded. The Earth is not only a passenger in this solar system, it carries something of its own. The first night after the sun disappeared would feel, to someone sleeping, like any other night. The second night would be colder, noticeably colder. The air above land, which holds heat less effectively than ocean water, would have already begun to release what it stored during the final days of sunlight. In the middle of continents, far from the moderating influence of the sea, the cold would arrive faster. Nights that were already winter nights might drop sharply. Nights that were summer nights would begin to feel like autumn, then like winter, more quickly than any natural season. But along coastlines and over the oceans themselves, the change would be slower. The sea's thermal inertia is so large that it takes time, real time, weeks of it, to see the shift. And in that time, a curious thing would still be visible in the sky. Because even though the sun would be gone, the universe around it would not be dark. The stars would be there, all of them every night, with no competing daylight to dim them. A sky fuller and more layered than most people living near cities have ever seen. The Milky Way would be visible from every location on Earth, every clear night. The band of it hundreds of billions of stars. The flat disk of our galaxy, seen from the inside, would arch from horizon to horizon in a way that, for most of human history, before artificial light, was simply ordinary. What people used to see when they looked up. What navigators sailed by. What ancient storytellers wove into the shapes of the animals and figures they named in the sky. That sky would return, still cold, getting colder, but extraordinarily clear. There is something about that detail that I return to quietly. The disappearance of one star, revealing billions of others. The loss of the loudest light-making room for every quieter one. Stars don't vanish cleanly. The sun, if it were to simply disappear, as a thought experiment imagines, would violate the ordinary rules. In reality, stars change slowly. The sun itself is about halfway through its life, roughly 4.5 billion years old, with approximately another 5 billion remaining in its current stable phase. It will not suddenly be gone. It will change gradually, over timescales, so long they are nearly impossible to hold in the mind. But there is a stage of stellar life that offers a softer parallel to the thought experiment. When a star like the sun eventually exhausts the hydrogen fuel at its core, it begins to expand. Slowly at first, then more noticeably over millions of years, the outer layers cool and spread outward. The star becomes a red giant, larger, cooler on its surface, more diffuse. The sun will eventually expand to perhaps 100 times its current size, possibly reaching as far as the Earth's current orbit. At that point, it will no longer be a compact point of concentrated light. It will be an enormous, dimmer, redder presence filling much of the sky. But by then, the sun's light at Earth's surface will actually be different in character, less concentrated, more spread, warmer in color, and long before that expansion, the increasing brightness that comes with age. The sun has already brightened by about 30% since its formation, and will continue brightening. Will have changed conditions on the surface of the Earth in ways that will require adaptation. Life, if it persists that long, will have adapted. It always has. Life on Earth has survived changes in solar output before. Not on the scale of billions of years, but on smaller scales, variations in the sun's activity cycle, changes in the tilt and orbit of the Earth, ice ages driven partly by subtle shifts in how much sunlight different parts of the planet receive. Each time, the web of living things adjusted. Slowly, differently, but it continued. This is not a reassurance. It is just the pattern that the evidence shows. Somewhere, in thinking about the sun's absence, you find yourself thinking about light differently. Not light as a utility, not the practical thing that lets you see your hand in front of you, but light as a physical phenomenon with its own nature, its own behavior, its own relationship to time and matter. Light travels at approximately 300 million meters per second in a vacuum. That speed is not arbitrary. It is a fundamental constant of the universe, woven into the structure of space and time in a way that affects everything. The relationship between energy and matter, described by the most famous equation in physics, which says they are equivalent and interchangeable, depends on that speed as the conversion factor. The fact that atoms release light when their electrons drop to lower energy levels, the fact that chemical reactions can be triggered by specific wavelengths, the fact that your eyes can detect a single photon under ideal conditions. All of it traces back to the same underlying structure of how light and matter interact. Your body has photoreceptors in your eyes that evolved specifically to detect the range of wavelengths the sun emits most strongly. This is not a coincidence. Evolution shaped your visual system around the available light source. The peak sensitivity of human vision, the wavelengths we see most clearly, corresponds closely to the peak output of the sun's spectrum at the Earth's surface. You were built to see in sunlight. The sun's particular flavor of light is built into the architecture of your vision. There are also photoreceptors in your skin and in deeper tissues that respond to light in different ways, not for vision, but for signaling, timing, regulating the slow hormonal rhythms that govern your daily cycle. Ultraviolet light on skin triggers vitamin D synthesis. Light through the eyes at certain times of day suppresses melatonin, keeping you awake. The dimming of evening light signals the pineal gland to begin releasing it again. Right now, in the dark, your melatonin is rising. The absence of light is doing something in your body. It is telling every cell that it is time to repair, consolidate, restore. The dark is not empty. It is full of instruction. 3:14 p.m. The light that reaches your eyes on any clear night comes from distances that make the sun's 8-minute delay seem like no delay at all. The nearest star to our sun, Proxima Centauri, is 4¼ light years away. The light leaving it right now will arrive at Earth in 4 years and 3 months. The light you could see from it tonight, if you were outside, if you knew which faint reddish point to look for, left that star in the autumn of 2021. Whatever is happening there now, you will not see it until 2030. The stars you can see with the naked eye on a clear night span a range of distances from a few light years to a few thousand. Each point of light is a different depth in time. A photograph of the night sky is not a picture of the universe as it is. It is a layered composite of many different moments, each arriving at your eye simultaneously, each having traveled a different duration to get there. The night sky is a kind of temporal college. And then there is the soft band of the Milky Way itself, when you can see it. The stars in that pale diffuse glow are farther still, thousands of light years in many directions. Light that left its source before certain civilizations existed, before certain languages were spoken, arriving at your retina on an ordinary night and being processed in about 1/10 of a second into something your brain categorizes as a faint smear of light across the sky. That categorization is efficient. It is also, in some sense, a significant underestimation of what is actually happening. You are receiving messages from deep time every time you look up. Your eye is an instrument sensitive enough to detect individual photons, and those photons carry information about the temperature, composition, and motion of objects hundreds or thousands of light years away. You were built to do this. It costs you nothing. It requires no special training. Most nights, artificial light makes it impossible. But the capacity is always there, waiting. The sun produces its energy through nuclear fusion at its core, where the temperature reaches approximately 15 million degrees Celsius, and the pressure is 300 billion times the atmospheric pressure at Earth's surface. Hydrogen nuclei are moving fast enough and being compressed tightly enough that they collide and fuse. 4 hydrogen nuclei combine to form 1 helium nucleus. In the process, a small amount of mass is converted directly into energy. The conversion the famous equation describes. The amount of mass lost in each fusion event is almost unimaginably small. But the sun contains an almost unimaginably large amount of hydrogen, and fusion is happening continuously throughout its core across an enormous volume. The total energy released every second is equivalent to roughly 4 million tons of mass being converted to energy every second. And yet the sun is so large that it will continue doing this for another 5 billion years before it exhausts its core hydrogen supply. The energy produced at the core does not travel to the sun's surface quickly. The interior of the sun is so dense that a single photon of light created in a fusion reaction can take anywhere from 10,000 to 170,000 years to work its way through the solar interior, being absorbed and emitted millions of times, gradually moving outward through the radiative zone. It then passes through the convective zone, where hot plasma rises and cooler plasma sinks in slow churning columns, carrying energy toward the surface more efficiently. Finally, it reaches the photosphere, the visible surface, and from there it escapes into space. And 8 minutes later, it is here. That photon may have begun its journey 100,000 years ago, when humans were still in the early stages of spreading across the world. When certain mountain ranges looked slightly different, when the coastlines of continents were altered by lower sea levels during the last ice age. It has been traveling toward this moment for a very long time. The warmth still in your skin from today's sunlight carries something ancient in it. There is a process called photosynthesis that most people learned about in school. and then stopped thinking about in any detail. The basic summary is that plants use sunlight to convert carbon dioxide and water into sugar and oxygen. That much is familiar. But the mechanism itself, what is actually happening inside a leaf when light strikes it, is worth sitting with quietly. Inside every leaf cell are structures called chloroplasts. Inside each chloroplast are stacked membranes containing molecules of chlorophyll, the pigment that makes plants green. When a photon of a specific wavelength strikes a chlorophyll molecule, it excites an electron within that molecule to a higher energy state. That energized electron is then passed, like a baton in a relay, through a chain of proteins embedded in the membrane. Each transfer releases a small amount of energy, and that energy is used to pump hydrogen ions across the membrane, creating a concentration gradient, a kind of stored tension that is then used to synthesize ATP, the molecule that powers most biological processes. The entire first stage of photosynthesis happens in femtoseconds, millionths of a billionth of a second. It is among the fastest chemical processes in biology, and it is nearly perfectly efficient at capturing the energy of light. More efficient, in fact, than almost any solar panel humans have built. The sugar produced in a leaf on a summer afternoon may end up in a fruit that is eaten by an animal. That animal's muscles use the stored energy to move. Another animal eats the first. The energy moves up through the food web, diffusing and changing form, but traceable in an unbroken chain, back to a photon that left the sun 8 minutes before it struck a leaf. Everything that has ever moved under its own power on the surface of this planet, every running, swimming, flying, burrowing thing, has ultimately moved on borrowed sunlight, including you. The carbon in your body was once carbon dioxide in the atmosphere. A plant absorbed it, fixed it into sugar, and the carbon entered the food chain. You ate food that contained that carbon, and your body incorporated it into proteins, fats, structural molecules, the long chains of your DNA. The carbon in your bones, in your blood, in the neurons currently receiving the quiet signals of near sleep. All of it was recently atmospheric gas. Before that, it came from somewhere older. Carbon is not created on Earth. It was forged in the cores of stars that existed before the sun. When those stars aged and exhausted their fuel, they expelled their outer layers in expanding shells of gas and dust, some in slow stellar winds, some in the violent explosions called supernovae. That material drifted through space and eventually, drawn together by gravity, became part of the cloud of gas and dust that collapsed to form our solar system. The sun formed at the center. The planets formed from the remaining material. Earth formed. And the carbon that had been made in earlier stars was present in the rock and ice and organic molecules from which the planet was built. You are made of material that is older than the sun. Every atom of carbon in your body has a history that predates the solar system by millions or billions of years. It was inside a star. It was scattered through interstellar space. It was part of the early Earth. It cycled through the atmosphere, through ancient organisms, through layer after layer of geological and biological transformation before arriving here, now, as part of a body that is lying in the dark. Noticing this, there is something in this that keeps returning to me, quietly, not the scale of it. Just the fact that the material has been here all along, changing form, never lost. You are not mostly empty space, but the atoms that make you are. This is one of those facts that is technically true and often stated, but rarely allowed to actually land. An atom consists of a nucleus, protons and neutrons bound together, surrounded by electrons. The nucleus contains almost all of the atom's mass, but it is extraordinarily small relative to the size of the atom. If you enlarged a hydrogen atom to the size of a large sports stadium, the nucleus would be roughly the size of a marble at the center. The electron would be somewhere in the upper tiers of the stands, almost impossibly small, moving through a probability cloud rather than a defined orbit, not a tiny planet circling a tiny sun, but more like a tendency, a region where the electron is most likely to be found. If you looked for it, between the marble at the center and the faint presence in the stands, there is nothing. Or rather, there is the quantum field, which is not nothing, but it is not matter in any ordinary sense. It is a kind of structured possibility. The experience of solidity, the feeling of the mattress under you, the weight of a blanket, the physical realness of a hand, comes from electromagnetic repulsion between electron clouds. When two objects touch, their electrons never actually contact each other. They repel. What you feel as solid contact is an electromagnetic force acting at a distance between objects that are mostly, at their most fundamental level, open space inhabited by fields. This is not destabilizing. It is just the nature of how matter works at small scales and how it gives rise, collectively, to the reliable, touchable, restful world of ordinary experience. The blanket is real. The warmth is real. The body resting now is real. All of it built from ancient stardust, held together by invisible forces, lying in the dark on a cooling planet that still carries its own fire. The darkness outside is not featureless. Even on a night with no moon, no stars visible, clouds covering everything, the darkness has texture. The atmosphere above you is not still. It is a moving system, always air masses of different temperatures and densities pressing against each other, water vapor condensing and releasing latent heat. The slow global circulation patterns that carry warmth from the equator toward the poles and cold air back again. Weather is the atmosphere redistributing energy. almost all of that energy comes originally from the sun. The differential heating of the Earth's surface, land warming faster than ocean, equatorial regions, receiving more direct sunlight than polar regions, drives pressure gradients that become winds. Those winds carry moisture evaporated by solar heat over warm water, deposit it as rain over land, feed rivers that carve landscapes over geological time. The sound of rain, if you have ever fallen asleep to it, is the sound of the water cycle completing one of its loops. Water that evaporated from an ocean surface, carried inland by wind, falling now on a roof. Every part of that sequence, evaporation, transport, condensation, precipitation, runs on sunlight. On a night like this one, the atmosphere above you is doing all of this silently, invisibly, the way the body does its own maintenance work in sleep. The lungs exchange gas, the kidneys filter, the lymph moves. The immune system notes and responds. None of it requires your attention or direction. None of it pauses because your awareness has softened. The atmosphere is like that. It does not need to be watched to continue. If you trace any weather system back far enough, you find the sun. If you trace any ocean current back far enough, you find the sun. The great conveyor belts of ocean circulation, warm surface currents moving toward the poles, cooling, sinking, moving back along the deep ocean floor, rising again in cold upwellings that bring nutrients from the deep. These are driven partly by temperature differences created by uneven solar heating, and partly by salinity differences, and partly by the winds that the sun's heat drives across the ocean surface. The Gulf Stream carries warm tropical water northeast across the Atlantic, moderating the climate of Western Europe. Without it, winters in Britain and Scandinavia would be significantly colder than they are. The conditions that made certain regions agriculturally productive, that allowed certain civilizations to develop in the places they did, that shaped the particular histories and languages and cultures that produced the people who eventually produced you. All of this traces back, at some remove, to the particular way the sun's energy enters the Earth system and moves through it. You are not just made of stardust in a poetic sense. You are also a specific product of a specific climate in a specific region, shaped by specific ocean and atmospheric patterns driven by the sun's particular relationship to this planet. Your existence, in its precise form, required all of it, not just the biology. The whole system, the angle of the Earth's tilt that creates seasons, the distance from the sun that keeps water liquid at the surface, the magnetic field generated by the Earth's liquid iron core that deflects the solar wind and protects the atmosphere from being stripped away over geological time. A very particular set of conditions, all of them fitting together. Others have been running for long enough that something like you could eventually appear and lie down in the dark and notice them. Sleep itself is a solar phenomenon, not in a loose metaphorical way, in a direct biological one. The circadian rhythm, the roughly 24-hour cycle that governs your sleep and waking, your body temperature fluctuations, your hormone releases, your cognitive performance across the day, is synchronized to the rotation of the Earth relative to the Sun. The rotation period of the Earth is approximately 24 hours. Your internal clock runs on approximately the same period, not because it is perfectly set to that length, but because it is continuously reset by light. The photoreceptors in your eyes that feed the circadian system are most sensitive to blue wavelength light, which is, not coincidentally, others call the dominant wavelength of the sky during daylight hours, particularly in the morning. Morning light carries a strong blue component. It enters your eyes, reaches a small cluster of neurons in the hypothalamus, called the suprachiasmatic nucleus, and resets your internal clock to the current time of day. This happens every morning. Without it, the clock would drift. It runs just slightly longer than 24 hours on its own, and the daily light signal nudges it back into alignment with the planet's rotation. The sleep you are moving toward right now is the body following a schedule it has kept, reset daily by sunlight since before you were born. It is a habit billions of years in the making, passed down through every ancestor in an unbroken chain, all of them falling asleep in the dark on the same rotating planet, all of them reset each morning by the same star. Your tiredness tonight is the sun's doing. In the most literal sense, in the absence of the sun, the circadian system would eventually lose its anchor. This has been studied in small ways. People who spend extended time in environments without natural light, polar researchers in winter, volunteers in windowless bunker experiments, find that their sleep and wake cycles begin to drift. Without the daily reset signal, the body follows its own slightly longer than 24-hour preference. Sleep gradually shifts later each day, cycling slowly around the clock over weeks. It is not chaos. The rhythm persists. It just loses its connection to the external world. There is something in that worth noticing. The body's timekeeping is internal. It does not require the sun to run. It only requires the sun to stay aligned with the larger rhythm of the world outside. Remove the signal and the clock continues, just on its own time, gradually drifting away from shared time. Human beings have their own internal rhythm. It predates consciousness, predates the nervous system in its current form. Single-celled organisms have circadian rhythms. Cyanobacteria, some of the oldest living things on Earth, have a circadian clock that has been running for perhaps 2.5 billion years, since before complex life existed. It is one of the most conserved features in all of biology, meaning it appeared early and was so useful that almost nothing has abandoned it since. The oscillation between activity and rest, between engagement and withdrawal, is not something imposed on life from outside. It grew from inside life. The sun gave it its daily calibration. But the rhythm itself came from within. You are not falling asleep because the day ended. You are falling asleep because something in you has always known when to be still. There are places on Earth where the sun does not set for months. In the high Arctic in summer, the sun circles the horizon continuously, dipping but never disappearing, the sky shifting through pale golds and pinks without ever reaching full dark. For people who grew up there, the experience of continuous light is ordinary. For those who encounter it for the first time, it tends to be disorienting in a specific way, not visually, but temporally. The body loses the cue it uses to mark the end of one day and the beginning of the next. Time feels different without the punctuation of darkness. And in winter, the opposite. Months of near continuous dark. The sun barely cresting the horizon for a few hours before sinking again. The human communities that have lived in those conditions for generations have found ways of structuring time that do not depend entirely on the sun's presence. Interior rhythms, social rhythms. The warmth of gathered people in firelit spaces becomes the anchor that light once provided. What holds the day together in that dark is not the sun, but relationship. The shared meal, the particular quality of returning somewhere warm after cold, the knowledge that certain people will be there, the sun, organized time for the whole history of our species. But beneath that organization, something else was running. The web of connection between people and the places they knew, between the living and the accumulated memory of those who had been there before. That web does not require sunlight to hold. It is holding right now, in the dark, while you rest. The warmth you feel right now is not only yours. The heat of a body at rest is a byproduct of metabolism, the continuous chemical activity of cells doing their maintenance work, converting stored energy into the molecular currency that powers every process. That conversion is never perfectly efficient. Some energy escapes as heat. The body runs slightly above the temperature of its surroundings, radiating warmth outward continuously. But the stored energy being converted comes from food. And the food came from plants or from animals that ate plants. And the plants built their stored energy from sunlight. The warmth leaving your body right now, moving into the air of the room, is solar energy completing a long and indirect journey. It left the sun as radiation. It struck a leaf. It was captured by a chlorophyll molecule, converted to chemical energy, stored in a sugar. It moved through the food chain, was eaten, was metabolized, was used to build the proteins and fats that your cells now burn slowly in the night. The heat releasing from your skin is the final form of that journey. It is not dramatic. It is just continuous. The sun's energy moving through matter, changing form, eventually becoming the warmth of a resting body in a dark room. After that, it dissipates into the air, into the walls, into the night. It will eventually radiate outward from the planet into space as infrared radiation, as the Earth maintains its energy balance. Everything that arrives from the sun eventually leaves again. The planet is not accumulating energy. It is a transit point, a temporary arrangement of matter through which energy flows. You are also a temporary arrangement, not fragile, just transient. The energy moving through you will continue moving long after the particular form it takes right now has changed. Rest is not absence. This seems worth saying quietly, because the body in sleep is sometimes described as if it has simply turned off, as if waking is the real state and sleep is the pause between. But the evidence runs the other way. During sleep, the brain is highly active. Different kinds of activity, yes, less of the outward, directed processing that characterizes waking attention. More of the inward consolidation that organizes experience into memory, clears metabolic waste from neural tissue, repairs and restores. The glymphatic system, a network of fluid channels around blood vessels in the brain, becomes significantly more active during sleep, washing cerebrospinal fluid through brain tissue and clearing proteins and other metabolic byproducts that accumulate during waking hours. The brain cleans itself in sleep. It can only do this properly when you are not using it for other things. The heart rate slows. The blood pressure drops. The muscles release their tone. The digestive system continues its work quietly. The immune system, freed from the demands of full alert, waking activity, turns its attention to long-term maintenance and response. The body is not waiting during sleep. It is working on the things that cannot be done while you are awake and moving through the world. Sleep is when the repair happens, when the memory is filed, when the emotional register of the day is processed and integrated. You are not pausing right now. You are doing something essential. The sun, in one framing, is a giant engine of order. This sounds paradoxical, because the laws of thermodynamics describe a universe trending inexorably toward disorder, toward equilibrium, toward maximum entropy, toward the state where no more useful energy transformations are possible. Everything, given enough time, runs down. But locally, temporarily, energy flowing through a system can create and maintain order. The sun pours low entropy, concentrated energy into the Earth system. The Earth uses that energy to maintain complexity, to sustain weather patterns, chemical gradients, biological structures. Life itself is a form of maintained order, built and sustained by the continuous flow of energy from the sun through the biosphere. A living cell is extraordinarily ordered, compared to the molecules it is made from in isolation. To maintain that order requires continuous energy input. Stop the energy and the order degrades, not immediately, but inevitably. The sun is what keeps the Earth's surface from settling into equilibrium. It keeps the atmosphere churning, the water cycling, the living things metabolizing. It is the source of the gradient that makes almost all earthly complexity possible. When biologists look for life elsewhere in the universe, they look for energy gradients, for situations where energy flows from one state to another, creating the conditions where complexity can maintain itself. A star and a planet at the right distance is one such situation. Hydrothermal vents are another. Perhaps there are others, stranger ones, that have not been discovered. But here, on this planet, in this room, the gradient is solar. The order that is you, the specific, improbable, finely maintained order of a living body, is being sustained tonight by the stored products of that gradient. Even in sleep, even in the dark, the order holds. There is a quality that deep familiarity has. When something has been present for long enough, it stops being a thing you notice and becomes a condition of noticing. The sun is like that. It is so woven into the structure of how everything works that it has become invisible in the way that the most fundamental things become invisible. The air is like that too, and gravity, and the temperature range that keeps water liquid. These are not things most people think about on ordinary days. They are simply the conditions inside which thought happens. They recede to the background so completely that they can start to feel like nothing, like the absence of something, rather than the constant presence of something. But they are not nothing. They are the most present things there are. The sun is present right now, even on the other side of the earth, even in your dark room, even in your sleep. It is present in the warmth still in the walls, in the melatonin rising in your blood, in the rhythm that is pulling you toward rest, in the carbon of your body and the oxygen in your lungs and the water. Moving through your cells, all of it assembled and maintained by processes the sun set in motion or continues to sustain. Absence is hard to imagine because presence is so complete. The thought experiment of the sun disappearing is difficult, not because the consequences are frightening, but because the mind keeps finding the sun already everywhere it looks. Every thread of the inquiry leads back to it. Every question about what would change reveals something else that runs on solar energy, something else that would shift, something else that is quietly and completely dependent. It is woven through everything. The way certain things are, not added, not decorative, but structural. Part of the loom, not the fabric. Stars are not rare. The Milky Way alone contains, somewhere between 100 billion and 400 billion of them, depending on how you count the faint, small ones at the low end of the mass range. The observable universe contains perhaps 2 trillion galaxies, each with its own population of stars. The total number of stars is estimated to exceed the number of grains of sand on all of Earth's beaches and deserts combined. The Sun is not unusual among stars. It is a fairly average yellow dwarf, slightly more massive than the median, slightly brighter, but not remarkably so. It is not among the largest, not among the hottest, not among the oldest. In a census of stars, it would not stand out, and yet it is the one whose light built you, whose energy runs through every system that sustains you, whose rhythm organizes your days. There is a word in certain languages for the particular feeling of something being singular, not because of rarity, but because of relationship. This star, of all stars, is the one in relationship with this planet, this ocean, this atmosphere, this web of life. Other stars shine on other worlds. Whatever forms of order exist, there are sustained by those stars in the same fundamental way. But the relationship between life and its local star is always specific, always intimate in the physical sense, not emotionally intimate, but intimate the way a key is intimate with the lock it was made for. The particular wavelengths, the particular intensity, the particular distance, the particular duration. The Sun did not make life on Earth because it is a special star. It made this life, this particular flowering of complexity, because it has been here, constant, for long enough. Constancy is its own kind of gift. The night is doing something to your body right now that requires no effort from you. Not metaphorically. The drop in light that happened hours ago. The slow dimming of the afternoon into evening. The particular quality of the last light, before dark, set off a cascade of small hormonal changes that have been unfolding ever since. Core body temperature has been falling slightly, not dramatically, a fraction of a degree, but measurably, reliably, in a direction that makes rest easier. The blood vessels near the skin dilate a little in the evening, releasing heat outward, cooling the core. This is why hands and feet often feel warmer just before sleep, warmth moving from the center to the surface, dispersing, the body preparing itself from the inside. None of this requires a decision. You did not choose it. It was already in motion before you lay down. The room is the right temperature for this. The dark is the right condition. The quiet is the right sound. Everything that needs to happen is already happening, on its own, without your management. There is a particular quality to this kind of process, biological, automatic, ancient, that has something restful in it even just to recognize. The body knows, not in a thinking way, in a deeper way, older than thought. It has done this so many times, across so many generations, that it does not need reminding. Your only task right now is to be present enough to notice that the task is already being done. Let the temperature fall. Let the weight settle. Let the breath find its own pace, which is slower than waking breath, fuller in a different way, less effortful. The sun has been setting on sleeping animals for hundreds of millions of years. Sleep, or something very like it, is ancient. Fish show periods of reduced activity and responsiveness. Insects have rest states with measurable changes in brain activity. Even the simplest animals with nervous systems show oscillations between activity and rest that resemble, in their basic structure, what mammals call sleep. The pressure to rest builds during waking hours. A molecule called adenosine accumulates in the brain as a byproduct of neural activity, creating a growing sense of fatigue that is relieved by sleep as the adenosine is cleared. This is why caffeine works the way it does. It blocks the receptors that detect adenosine, masking the signal without reducing the accumulation. The fatigue is still building behind the mask. But here, now, there is no mask. Whatever the day accumulated, the clearing is beginning. The adenosine is being addressed. The metabolic waste in the neural tissue is beginning to move. The consolidation of the day's experience into longer term memory is starting its work. All of this is why the approach of sleep carries a particular quality, not just the absence of energy, but a kind of gathering. A turning inward. The sun sets. The adenosine speaks. The body obeys a rhythm older than mammals, older than the first creature that could close its eyes. Rest is not something you invented. You inherited it along with everything else. Think for a moment about what the Earth looks like from space at night. Satellites have photographed it. The images show the dark side of the planet. The hemisphere turned away from the sun, mapped with clusters and threads of artificial light. Cities visible as bright nodes. Highways as thin luminous lines connecting them. The overall shape of inhabited coastlines traceable in light, even in the absence of the sun. What those images show is that humans have created a partial substitute for sunlight. Small, local, not remotely as powerful, but enough to extend the usable hours of the day and push back the natural signal of darkness. Enough to keep some part of the brain's alerting system engaged past the hour when it would naturally release. But even with all that light, even in the brightest cities, the underlying rhythm persists. People in dense urban environments still get tired, still sleep, still have circadian rhythms, though they may be disrupted or shifted compared to those living in more natural light conditions. The rhythm is robust. It is not easily overwritten. The electric light is very recent, a few generations old at most. The circadian system is billions of years old. It accommodates the new input, adjusts around it, but does not abandon its fundamental structure. Somewhere beneath the ambient glow of the modern world, the old rhythm is still running. the one calibrated to the actual star, the one that knows dark means rest, that knows the body needs the absence of light as much as it needs the light itself. You are in that dark now. The real dark, or close enough. The old rhythm is doing its work. There is a state between waking and sleep that has its own texture. Researchers who study sleep call it hypnagogia, the transitional zone where the mind is loosening its grip on directed thought, but has not yet entered full sleep. Imagery can arise spontaneously, unconnected, vivid, but not quite narrative. Sounds can seem louder or stranger. The sense of the body's edges can soften. Sometimes there is a sudden muscle jerk, the hypnic jerk, a brief involuntary contraction, sometimes accompanied by a brief sensation of falling. This is common and harmless, a quirk of the transition between the muscle tone of waking and the reduced tone of sleep. Possibly a remnant of an older reflex, possibly just a byproduct of the shift in neural states. It means the descent is progressing. The body is crossing a threshold. The images that arise in hypnagogia are not dreams in the full sense. They are more like the mind's ambient, static becoming audible as the louder signals of directed thought fade. Faces that belong to no one familiar, landscapes that resemble somewhere but are not anywhere specific, words or fragments of sentences that seem meaningful for a moment and then dissolve before they can be held. Most people pass through this zone quickly, without remembering it. But when sleep comes slowly, or when the body is very tired, the hypnagogic state can stretch. You can observe it happening for a little while before observation itself softens and dissolves. You may be somewhere near that threshold now. The thoughts may be coming a little looser, the edges of things a little less defined. That is the direction. That is exactly right. The sun will rise again. Not for you, not right now. You are moving away from that, into the restorative dark, into the place where the body does its quiet work. But the fact of it is worth carrying lightly as you go. On the other side of the planet, right now, a sky is brightening. The atmosphere is beginning to scatter the light from a sun still below the horizon. That blue, gray, pre-dawn quality that has no color yet, but already has a directionality, a sense of something arriving. Birds are registering it before humans do. Their circadian systems are slightly more sensitive to light, and they begin their morning activity, the singing, the movement, before the sky is fully bright. In a few hours, here, the same thing will happen. The light will begin before the sun appears. The room will slowly distinguish its edges from the dark. The world will reassemble itself from outline to detail. But that is later. That is for the body to arrive at on its own. Right now, there is only this, the dark, the warmth, the breath, the weight of the body known from the inside. The sun has set. The rhythm is running. The restoration has begun. The body already knows everything it needs to know. The shoulders can be heavy. The jaw can be easy. The breath can do what it does without any help. Somewhere out there, the planet turns. The oceans hold their warmth. The deep earth runs its slow fire. The stars send their ancient light toward a surface that is, right now, resting. You are part of that surface. Part of the planet's night. Part of the long rhythm. You are exactly where you are supposed to be. The dark is safe. The warmth is real. The rest is already here. Good night. Sleep well. The sun will find you again in the morning, the way it always has, the way it always does. You don't need to wait for it. It already knows where you are.